So here we are. So this is an example of the user-defined function. So you can have another user-defined function. Right? Functions are the backbone of writing reusable scripts in Python. Right? Without functions, you will be trapped in repeating yourself every time you want to get some certain stuff done. That's why functions are like pretty important. So I'm just trying to look at an example of function that we can also have here. So let's say you want to write a function to detect, write a function to detect odd or even number. I think we've already done this, right? And just for a just for clarification, hash then texts are used to comment, right? The same way you use double dash to comment in SQL, use dash to comment in Python. So let's say you want to write a function to detect odd or even number, right? So like I said, it starts with the keyword def. So you can name the function whatever you want. You can say define the function as detects odd or even. And don't forget the function would have to take in an argument, right? Like let's call the argument x or y or anything at all. Let's call it y. Fine. So if y is less than, or if y um, is divided by 2 and the answer is equal to 0, right? Print string of what? String of y plus is an even number. Else, right? There's a need to put all this indentation, right? I think we talked about indentation. Points string string of y plus is an odd number. So I've defined the function. I can now use it on whatever, right? Detect order even detect order even three. Oops. All the same. Okay, I think I wrote stry here instead of st. So let me rerun that and rerun my function. Let's rerun the function on on three now. Yeah, so there you have it. Three is an odd number. So this is just to show the structure of a function and how you can actually define your own functions, right? So that's it. Um, so the next we've got, I think I've talked about your NumPy. So this is an example of another function, right? This is just a conditional statement. Age is equal to 18. So if the age is greater than or equal to 18, print you are an adult. Else print you are not an adult. And since age is actually 18, and this is greater than, and the statement is defined as greater than or equal to 18, right? It's saying you are an adult, right? Gender is equal to female, right? If transgender, gender is equal to male, transgender is equal to male, false, right? And you can also use name is equal to Ada if name is equal to John, print phone number. So this can be used to as an authentication system where set the ground rule and you say if the input matches the ground rule, you say phone unlocked. But if the input does not match the ground rule, then tell it to enter the correct name. So you can also, these are methods, right? These are what we call methods. Methods. methods, right? So when you look at methods, if you see hello dot capitalized, methods are simply they are functions, right? But they are usually at the back of what they are acting on. So the conventional style of writing a function is you write the function, then you put the argument inside the bracket in front of it, right? That's the conventional way of writing a function. But when it comes to methods work more or less like a suffix, right? They come at the back of what they are actually what they are actually acting on. So that's how you have this hello dot capitalized, right? It is acting on hello, but then it is just at the back of hello. Then it capitalizes hello. Then you have that. Then you have this A is equals 1, 2, 3, 4. A dot append 5. Append is simply adding another digit or another number to the list, right? Then you have this A is equal to that. Then if I say that A dot append 6. And I print A. So you have the one that contains 6. So if I say A dot append 100 also, also have that, right? So if I have a list of numbers, let's say p is equal to, or let's say x is equal to mango, apple, carrots, and let's say watermelon, say I have that list and I'm trying to capitalize x dot upper. Well, list has no attributes or paths, so what can we do instead? Let's take it individually. So upper, all these ones are also, they are also, they are also, this is also an example of a method, right? So um, you can write a function that converts all the items in X to a capital letter to capital letters. That's going to be your assignment one. So let's move on. So you can also have, this is another example of a list of a function, right? You have a numerical list that contains 20, 60, 170, 30, 40, 200, and all of those. And you want to be able to, so what this function is doing in essence, what this function is doing in essence is to be able to produce a new list that adds that adds 10 to that adds 10 to the entry, that removes 10 from the entry if the item is less than 50, and adds 10 to the entry if the item is greater than 50. Right. So that's why we have this. So we're saying that, so the numerical list, the new list is this. So for number in the numerical lists, right? If num is less than 50, reduction is going to be the particular number minus 10, and you are going to have a new list which is going to append the reduction, right? Else, item is if the item is less than, or if the item is greater than 50, then right. So the main condition is if the item is less than 50, it should add, you know, a reduction of minus 10 to the list. But what if the item is less than 50? So if the item is now greater than 50, it should append the increase. If it is less than 50, it should append the decrease. If it is greater than 50, it should append the increase, right? And at the end of the day, it should print the numerical list, right? And also should also print the new list, right? If we do not like specify this new list, it's simply going to just print the numerical list that is specified from the onset, right? But we ask it to also print. You can put print, you can also put the item in here, right? You also have it to print the new list that it has generated, right? So you can see the item here is great, it's less than 50, and it's point its reduction. Item here is greater than 50, it points its increment. Here is greater than 50, the increment. Yes. Less than 50, the decrease. So how that's how you know the function usually works. It allows you to be able to just have something that. So this is a for loop, right? It's not a function. This is a for loop. If you want to like convert it to a function, you have to use the word df, like define, right? You have to start with the keyword define and actually name your function, give a name to your function, right? This is what I want to call this function. And whenever you need to use the function, you just write the function and put whatever you want inside the argument, right? Do you get, do you understand, or you want demo, some demonstration?
It is actually confusing because for this new list I can only see the brackets. Like, isn't like there's any values there, and in the output I'm seeing 10, 70, 180, which is quite different. I don't know, it's just confusing.
Yeah, so the thing is, so this is a list. We have a list. There's an original list, right? Do you know what a list is?
Yeah, and like an array of values.
Yeah, so that's a list. So this is an example of a list. Lists are characterized by normal square brackets and that contains entries which are separated by comma, right? That's it. So this is a list, right? This numerical. This is a list, and you want to produce a new list that is going to be that is going to be like an extension of the original list that you have. It's just like a function, right? But it's not a function because you are not defining any function here. If it were to be a function, you are going to start with the keyword def, like you did up here. Yeah, like we did up here. If it's to define a function, it starts with def, define, detector.e1, and or even here, define area, right? If it's to be a function, it starts with that def, like you're actually defining a function that can be used on anything. But this is a for loop, right? For loop works. For loop works as an iteration. I think there are even a couple of for loops up here. So this is a for loop. For loop works as an iteration. For loop is going to say for I in range 2 print I am a superman. Let me just do that. So that's how for loops work. For loop is going to like loop through every entry inside a list or inside an array to create a particular condition, to execute a particular condition for loop. So there's difference between if loop and for loop. So I can simply say for I, let's say range. I say range two for an instance. Two is range two is like I want to say 0 1 2, right? Or 0 comma 2 start stop, right? If I put three arguments, that's start, stop, step, range, 0 comma 2 comma 1. So for excuse me. Still giving importance. So this is meant to be start, stop, step, right? I don't know why it's bringing all this. Okay, let me use a simple range, which is like 1 to 1 comma 2 comma 3 comma 4. So this is a simple range of item, which is also a list. So so if I want to use for loop, if I want to use for loop, I can say, sorry, say let's call this my list. So I know that this is my list. So I can say for I in my list, right? Find Superman. So what is so forget this I is mainly is just for iteration, right? It's just to iterate through the list, like just to iterate through the list, meaning it's to like count every steps across the list. So and it's going to like print me this, right? So it's able to print how many I am a Superman 1, 2, 3, 4. So that's how for loop works. For loop is just going to iterate through whatever you have, and whenever it is able to like successfully move through the items in the particular item in the list or the particular item and whatever, it prints something, right? So that's how it works, right? Do you get how for loop works now? Do you get? So that's how for loop works. Hey, hello, Sinat.
Yeah, yeah, yeah. I get.
So that's how for loop works in the basic form. So that's what is transferred to this place as well. Fruit is equal to apple, banana, and orange. And for fruit and fruits, print fruit, print fruit dot upper. So this is basically going to print fruit and also print fruit dot upper, right? You can see that it initially prints fruits, which is apple, and the upper, which is apple. It's printed banana, right? And also printed the upper, which is banana. It printed orange and also printed orange, which is upper, which is capital. So this can as well be anything. You can say for I in fruits, right? It's just for loops are just used for iteration basically, to go through a list and execute the command whenever the condition is met. And there's really no point. You are not setting any condition other than when you loop through this list and you're able to like loop through for every item you're able to like loop past, you can execute this particular command, right? So that's how it works. Um, there is no condition. For if statement, there is actually a condition, right? If this is this, this should hold. If that is that, this should be the case. But for loop, there's no condition at all, right? You're just simply iterating. So for this one now, if y is divided by 2 and the remainder is 0, you should do this, else you should do this. For for loop, there's no condition. You can just say for I in whatever particular command should be executed. That's how it works. Which then brings us to this particular one. Right. So this is a list, so this is a list. So now I create a new list. If I did not create this new list, it would have just simply mix up everything, right? So that just mixed up everything. Right? You can see that it's mixed up everything. 10, 70, 180. So that's why a new bracket or a new container was created for it. An empty container at that. Where is it? I don't know why is this so slow? Why is this slow like this? So this is a new container. Then you say for num in num list. You can as well say from for I in num list. This is a numerical list. Um, this is combining for loop and if statement this time around, right? Of num in num list. For if num is less than or equal to 50, reduction should be equal to num minus 10. Then new list dot append reduction, right? This is a method, right? Else, that is if the condition of num less than 50 doesn't hold, if that condition doesn't hold, it should increase equal to num plus 10, then new list dot append, right? Then print all these guys. So there you have it. So I guess that is that should be clear. How that's how for loops and if statement can work together. So this is another subtopic: dictionaries, frequency tables, and functions. We've already talked about functions, so this is just going to be So you have dictionaries and frequency tables, functions in Python, right? Dictionaries are data structure that store key value pairs. They provide fast access to values based on their associated keys, and frequency tables can be created using dictionaries to count the occurrence of each unique value in a data set. Functions, right? We've talked about functions before. Functions in Python are reusable blocks of code that perform specific tasks, right? They help modularize code and improve code reusability. Right? When you start, let's say you want to do data science, for instance, they will tell you that it is important to know how to write functions when it comes to train an AI model, right? When you are just starting out, you write your you write your code, whatever code you are writing, you write it in a rather straight and plain way, or linear way. Should I say linear? But at some point, you realize that your code has to be modularized. What that means is it has to be like reusable, and you can only achieve that by using functions, right? So let me just go back. What are dictionaries? Dictionaries of values in keys and values. Key and values pairs, right? You have a dictionary here, students equals name John, age 20, grade A. So you have students name John, age 20, grade A. This is the key, this is the value. This is the key, this is the value. This is the key, this is the value. Right. So that's why they are called dictionary. For every key, there's a corresponding value to it. And if the key is a string, the rule demands you wrap it in a quotation mark. Right? Just like this. But if it is an integer, you can just leave the value there as an integer. So this data type is the dictionary, and we try to check the data type after writing it. Type. Type is dictionary, right? So you can also have what's it called? Let's say what other key value pair can you think of? Let's say we have a key value pair of, let's say, a phone profile, right? Can be a phone profile or a phone spec, rather, a phone spec, right? And one thing about dictionaries is that they are characterized with curly brackets. Curly bracket, the same way lists are characterized by square brackets. Dictionaries are characterized by curly brackets. So, like I said, they go occur in pairs of keys and values. So, let's say you have a key. What do we normally observe in a phone spec? You observe the memory, right? Internal memory, internal memory, right? Uh, you have to wrap that in inverted comma, of course. So the internal memory can be, let's say, 256 for an instance. That's the value, right? You don't have to put that in an inverted comma. It's because it's an integer. So what other item do you check in your phone spec? You can check the color, color, color can be black, and all other things you check. You can check the camera resolution. Camera resolution can be whatever 72, right? So you notice that it occurs in pairs, right? The key and the value, right? The key and the value. The value can either be an integer or string, right? While the keys majorly are usually strings anyway, because they name um, the key and the value, right? You can also have another. What other aspect do you check for in a phone? You can check for the maybe display resolution or something. I don't know what range of value that is.
The battery.
The battery, yeah, you can check the battery or something like that. Yeah, battery capacity, and most phones nowadays are using 5,000. So yeah, so this is an example of a dictionary. So if I want to like reference an item from the dictionary now, I can just say what is the phone spec and dot gets method gets color. So it's going to tell me it's black. It has already been defined. So it's black. Or phone phone spec. You can decide to like print out all the keys, dots, keys, right? Okay, let's start. Dot keys. Does it require this? Yeah, dot keys. So it's going to bring out all the keys: internal memory, color, camera resolution, battery capacity, or you say phone spec dot values. It's going to bring out the corresponding value. 256 black, 72, 5,000. So dictionaries usually occur in pairs, keys and values. And you can also mutate. Dictionaries are mutable, right? Mutable in the sense that they can be changed. Only tuples are the only like mutable data types or array types, right? But for dictionaries, they are mutable. I can decide to say that the phone spec, I want to change the battery capacity. I want to change it to 4,000. I prompt and I ask again, what are the values? Let's transfer transfer that's values. So you see, it has changed to 4,000. So that's to say that they are mutable. You can decide to change something in there. You can also you can index it by you can index it by the keys. You can also index it by by normal number. Indexing means you are trying to make you are trying to address a position, right? On spec one point. Oops, oops, oops. So you only index with your key. So that's how dictionaries work. Then frequency table. Frequency table. This is working like a for loop. This is a for loop in disguise, right? You have a list of items, numbers equals tada tada tada, all this 111 222. Then you have frequency, which is an empty dictionary. And when we're doing what was it called the other time? When we're doing num list, the other time we use a list, but here we use a dictionary. right? So freq equals an empty dictionary for number in numbers. You have that frequency of the number is equal to frequency dot get number comma 0 plus 1. So all of this is simply a for loop, right? That you know that just index the particular number, then tries to get that particular variable plus one. That is for every time that see in a variable like that, it adds one, and there you go. So these are an example of functions. We've already talked about functions. I am young. So you can define a function that a great function to print hello John exclamation mark then quit. Function with parameter define with name. So the parameter here is name, of course. Print hello plus name exclamation mark. Right. And by now you should be comfortable writing simple functions or reading simple functions. This is a function that is to add numbers, a simple arithmetic, right? Define add numbers, taking in arguments a comma b to print a plus b, right? So define add numbers a comma b, return a plus b. So after defining this function here, you can take the function, can apply the function on anywhere, anything to give you whatever you want. Right. Add numbers 22 comma 43. Right. So you can apply it on any other numbers to give you whatever you want. And then you have this addition equals add numbers. Print addition. Right. This is not necessary. This addition plus 10. I said maybe you are going to be printing. Print addition. Yeah. So this is this is going to be your second assignment. Did you take note of the first one? Did you take note of the first one? Hi, Sinat. Hello, are you there?
Hi, Amir, I heard you.
Like, did you take note
Yes.
of the first one? Like, did you get the first assignment, or I should come again?
No, no, I didn't hear the first one.
I think it's inside this notebook. I'm thinking of maybe sharing this notebook with you after the class because of the addition I've made. Or
Okay.
yeah, just need
Am I supposed to do the two? Are there two assignments inside it, or just the one in the basic section before intermediary?
there are two in the basic section now. The one I just wrote is the is the second one. I wrote one here. So this is the first one. Write a function that converts all the items in X to capital letter. So this is X: mango, apple, carrot, watermelon. So you write a simple function that converts all the items in the list to to capital letters, to a list in capital letter, right? And the second assignment is to write a function that takes in a list of numbers as input and returns a dictionary containing the frequency of each number in the list. That's the second assignment. So now intermediate Python. So we assume that once you have grasped the basics, it's time for a deeper dive into intermediate Python. So it is in this part that you get to interface with commands that are necessary for data analytics. In this topic, we'll explore the libraries such as Pandas and NumPy, data cleaning techniques, plotting data using matplot library, then different types of plots for data visualization and data storytelling through data visualization. So these skills are going to be able to like make you visualize data and visualize insights from your data. Right. Data analytics with Python is just majorly about EDA, right? Exploratory data analysis, cleaning data, exploring data, visualization, and some maybe statistical tests and probability. Yeah, walaikum salam. Walaikum salam. Sir. So, that's it basically. So there's really no much deep stuff when it comes to uh, Python in Python for data analytics. Except maybe you are going into data engineering or data science. So the first item is NumPy. NumPy is a library, right? First of all, what are libraries? Libraries are just you can think of them as tools, inbuilt tools suite of tools that you can import that helps you like get your work done faster, right? And inside the tool pack, there are like different types of individual tools in there. You can think of libraries as tool pack, right? Just as we had analysis tool pack in Microsoft Excel. So when you want to use a library, it is important to import the library first. If you don't import the library is not going to work. So you have introduction to pandas and numpy here. So pandas as a library is powerful for data manipulation and analysis, and it provides data structure like data frames, series, which allow for effective handling and manipulation of structured data. Right. Sometimes even when you are working with image data, you still have to convert them to tabular data, and that's what pandas does for you. It is very very powerful in converting even non-tabular data into tabular data. Or even if you are like working with a tabular data, let's say the data you are working with is in CSV, when you want to work with it on Python, you still have to like actually convert it to a pandas data frame, like to tell it that oh, this is actually tabular data in pandas that you can work with. So you have pandas and you have NumPy. Then NumPy is shortened form for numerical Python. It is the fundamental library for numerical computing in Python. It provides multi-dimensional array objects and mathematical functions to efficiently perform calculations on arrays. All of these English users will tell you that it is the most suitable library for numerical analysis of anything numbers. So let's dive in. So we have, like I said, you have to firstly import the libraries. If you want to use any library in Python. So import numpy, import pandas as PD, import numpy as NP. If you want to import any library, like that's how it works. Import pandas as PD, import numpy as NP. We are trying to import cbon, import cbon as SN, right? That's how you import the library anyways. You want to import matplot library, so you just have to like import them. And creating a pandas series. To create a pandas series, you use the command mpd.series. Um, More like a real life example for what you are going to you are mostly not going to be using all this. They are kind of like really basic stuff. Let's say you want to work with a real data for an instance. It is important to know that Python pandas is what you are going to use. So you use the command pd dot read csv, and whatever location that your data is, you put it inside. So that is to tell you that without pandas, it is almost impossible to get started with any real data analytics project. So you have this and you say data equals pd dot series 135 np dot ANEN and 6,8. And you say print data. Um, I don't know if this is clear. Then usually the series is just a normal list, or say a normal list. The series is a normal list, right? Here we are trying to convert it to a panda series, and here we are trying to convert it to a numpy array, right? As series is to pandas, array is to numpy, right? So as you can see, this is how the panda series is output. This is how the numpy array is output. So a this is a first real test of how you work with pandas, right? I don't think the sales data is. I think I shared you the data set, right? I shared you the data set. Hello, Zinat. Have I shared you the data set?
No, I don't have this one.
So the sales CSV data. Let me share. Now, I'm going to share you on Telegram. And so let me just share you on WhatsApp. On WhatsApp. So that's it. I just shared you on WhatsApp, and I'm just going to be showing you. Do you have you said you have a Jupyter notebook now, right? You have an Anaconda installed, right?
Yes.
Have you tried using Jupyter notebook before?
Have I what?
Have you tried using Jupyter notebook before?
Yes.
You said you've tried Jupyter notebook before, right?